Hi everyone, this is topic 4.8 Introduction to Acid-Base Reactions, and this is taken from AP Chemistry College Board. In this topic, I'll be talking about what our acids and bases are and how do they react with each other and how the acid-base reactions are related to the water. So let's start. So before going into the details of the reaction of acid and base, first of all, we need to understand the Bronsted-Lowry concept. Now, according to a Bronsted-Lowry concept, an acid is the one which donates the protons and Bronsted-Lowry base is the one which accepts the protons. Now, what is the meaning of proton? Proton means H positive. Hydrogen having a positive charge. Now let's see a reaction which can explain this thing more. Here we have taken a Bronsted-Lowry acid and we are reacting with a Bronsted-Lowry base. Let me repeat it again. Bronsted-Lowry acid is an acid which can donate the protons, and that's why this H of this acid will go to B. Basically H positive of this acid will go to base, and the base is the one which will accept the proton. So this B will take up the H positive. Now when this reaction happens, it forms A negative and HB positive because HA has given up the H positive, so it is left with A negative, and this B has accepted this H positive, that's why it has become BH positive. Now whenever these products are formed, these are called conjugate acids and bases. One which is formed from Bronsted-Lowry acid is called conjugate base. Now why it is called a base? Because now it is A negative and it can accept H positive again. So that's why it's called a conjugate base, and this is called an conjugate acid because it has now H positive which can go away. So that's why this is called conjugate acid. This pair of this acid and this conjugate base is called conjugate acid base pair. Similarly on this side also, the pair of this Bronsted-Lowry base with this conjugate acid is called conjugate acid base pair. So whenever there is a reaction between Bronsted acid and Bronsted base, this is the thing what will be happening. The H positive will move out of the acid and will be accepted by B, the base. Now, what is the role of water in any acid-base reaction? Now, we know that acid is the one which is H positive donor, proton donor. So, if we take an acid that is HCl and we add it to water, this HCl will basically give up this H positive, and that H positive will be taken up by the water to form H3O positive. As you can see here also, that when the acid that is HCl will react with H2O, this will form H3O positive. Why? Because the H positive of HCl will move out to H2O and it will form H3O positive and it will be left with Cl negative. So this parent acid is forming a conjugate base, and similarly a base is forming a conjugate acid. Now let's see what happens when a base is added to water. So when a base is added to water, we have taken an example of NH3. So when NH3 is added to water, this NH3 being a base will try to accept H positive, and that will come from water. So it will form NH4 positive and OH negative. This OH negative has been formed from water when it gives up the H positive to ammonia, and here the conjugate acid will be NH4 positive and OH negative will be the conjugate base. So these two reactions show up here that water can basically act as both the acid as well as base. Bronsted acid, why? Because it can give up the protons, and Bronsted base, why? Because it can take up the H positive. Now this reaction with water can basically help you to find the strength of acids and bases. Now when we are talking about an acid which is HF, when it reacts with H2O, this HF will give up the H positive and it will be taken up by the water to form H3O positive and F negative, and this F negative anion will be more stable. It means that it can remain in that state for a longer time. And when we are taking ammonia ammonia and reacting it with water, it will form H3O positive and NH2 negative. We have taken another acid which is CH4. So when this CH4 is reacting with water, it's forming H3O positive and CH3 negative. In all these reactions, these acids are giving up the H positive and they are taken up by the water. But what is the difference between these all? The F negative which is formed here in the first reaction is the most stable, and CH3 negative which is formed in the last reaction is the least stable. So it means that CH3 negative formed from the acid will be the least acidic, and similarly the F negative which is the most stable is formed from HF, so HF will be the most acidic. So reaction with water of any acid can basically help you in finding the strength of that acid. Same thing can be done for the bases also to find their strengths. So that's all for now in this topic, acids and bases. If you like the video, please subscribe to my channel and press the bell icon.